going to talk about the equipment so you have an understanding of what you're dealing with for entrapments is our primary focus, I'm pretty sure. If you have questions about any of the hardware or something you've seen that you probably won't see on this one since it's a little older, quite a bit older, just speak up. I'm going to talk about the this guide for emergency personnel. This is from the American Society of Mechanical Engineers, A17.4. You should be familiar with this. It really talks about how to safely get people out of an elevator that's stuck, and what procedures you should and shouldn't do. The things you shouldn't do are probably just as important as the things you should do to keep yourself safe and the occupants and anybody that's working in the scene. This manual also talks about operation of firefighter service, which almost all elevators should have at this point in time. In the early days, code changed in the 80s to require at least one elevator in the building to have fire service. Now all elevators are required to have it. Doesn't matter how tall the building is or anything. So they should all have some form of fire service. How does it function? Two ways basically. One is key switch operation, and the other way is by initiating devices in the elevator lobby, and in the machine room, the equipment room, if you have an equipment room. And I'll talk about some of those differences too, with stuff you might run into with really new equipment, may not have an equipment room. To recall the elevator, well, let me back up a minute. Talk about some code things first. Sorry. So there's numerous codes that govern elevators. Our main elevator safety code is ASME A17.1, which the state adopts. The State Building Fire and Fire Prevention Building Commission adopts codes to include all the NFPA codes and building code and all those things. And I was a commission member for about 3 years. The state code requires this key box to be located near every elevator, or if you have a group of elevators, there has to be at least one near that group of elevators. Now, if you have another elevator in this building on the other end of the building, there'd have to be a key box next to it too. And it's required to have all the keys to operate the elevator in this box. Now, this is not the same thing as your Knox box situation, where that's a different code that requires those for you guys to be able to get in buildings, right? So this is part of the 675 IAC code 21-5 that requires all the elevator keys to be in this enclosure also. So I've had issues in the past where a fire marshal will come on a building and say, we need all those keys in that box to be out front. I'm like, no, you need another set of keys to be out front because these are still required to be here. So what you need in here is the machine room key to get into the equipment room, all the key switches that operate the elevator, one of each in here. Now, if you had a group of 2 or more elevators, you need 2 or more fire service keys, because we can operate the elevator on fire service inside the elevator, and I'll show you that. So we need 1 key for each elevator if we had a group of elevators.
So which one of our keys opens that box?
Now, the key for the box is a standard key, which is part of the state code also. It's called an SI2 key. It's called an SI2, that's the designation of the key. But that box is the same throughout Indiana. Find the right key for fire service. Right. So we key it on. If the elevator isn't at this floor, it's going to recall to this floor. If it's at another floor with the door open, let's just do that. I'll send it up. This key switch, you'll notice, says reset off and on. Older stuff might say bypass off and on. There was a code change in 2000 that changed that. So in the bypass position, those older ones would actually bypass the initiating devices if it was keyed to that position. That would allow the elevator to operate if you had a faulty alarm. But you can't remove the key when it's in that position. It's not meant to be left in that position. You can't remove the key in the bypass position. So the elevator went up.
So if you do that, that's phase one, trying to recall.
Phase one recall. So you can hear a buzzer going off.
Okay, and that's your audible.
Yeah, there should be a light inside the elevator too, I
If you had a
believe.
bank of 4 elevators down
They would
there,
all be coming down.
what if one of them didn't?
If there was a malfunction, it would be the only reason it wouldn't, or somebody's holding the doors open. Now, on the door operation, there's an indicator light in here that's lit also. And on the door operation, these have an infrared light curtain that is the door protection, so if somebody's walking in, it's the doors. Now that can be affected by smoke, so it's required to disable that. So there's codes that
Because
determine.
they can't tell between a person.
Right. And it will go at reduced energy to try to force the doors shut. How fast or how hard we can close doors there's a kinetic energy limitation in the elevator code, and we can close the doors at a reduced kinetic energy without protection. That forces the doors shut unless something is physically stuck in the door. And then it should return. But there's a buzzer going off and a light's on in there telling people, hey, we're trying to do something here. Now the general public, they don't know what all that means usually. It's just, but our indications, we know. But if an elevator's broken and it doesn't recall, it's going to keep trying to recall until it gets fixed. Now it might not get fixed until an elevator mechanic shows up and fixes it. And then it will have to recall before it can go back to automatic operation.
Okay.
Once on newer controls, and most of what I'll say is probably geared towards the really newer stuff, 20 years or newer, has to memorize, when fire service is activated, it has to memorize that. So if I reset the power, it will still be on fire service operation. So you can't clear that condition without keying it to reset or the initiating devices being reset because they're cleared. We won't do that. The alarm company or building people usually have to.
If there's something going on that's in the elevator shaft, like there's some kind of a fire in the elevator shaft, or because we've got one in particular that was at Carrier. Carrier actually had a fire that was in the bottom on oil that was in the bottom of the shaft. Okay, there's detectors that sometimes, I guess, that are in those.
Not always, not usually actually, because the only time you're allowed to have initiating devices inside the elevator shaft is if there's a sprinkler system in the shaft, or it's an initiating device to activate a smoke mitigation system, dampers that would vent the smoke out of the hoistway. They're allowed to be operated by an initiating device. Let's say that up to the 2019 version. The 2022 was just published a couple months ago, and I just got my hands on it. I don't know if they've changed that part, but no initiating devices are allowed in the hoistway unless you have those conditions, sprinklers primarily. And then it's a heat detector within 2 feet of the sprinkler head, so that hopefully the heat detector activates and shuts off power to the elevator prior to sprinkler activation. That's its sole purpose. We call it shunt trip operation. It kills power before we put water on it. Same thing with equipment rooms. If there were sprinklers throughout the building and in the equipment room, same thing. They have to have a shunt trip. So I don't know if I answered your question or not, but
Well, yeah, you did. I mean, it was just like going into phase one, recall, because when we're going to use the elevators to do any kind of firefighting stuff, going into phase one to recall everything, or like this isn't necessarily so much like somebody stuck in there,
right.
which I'm going to probably leave you alone on that. Let you like, hey, this is probably what I do first, second,
Yeah,
third.
and if
fourth.
you show up and it's already on recall because of an initiating device, I would, and I'm sure you guys do this already, but your due diligence on why.
Right.
What alarm activated? Is it in the hatch, in the hoistway?
Right.
Is it in the equipment room? And where the elevator is might be a cue if you know the building. Because if it's in the machine room, if the machine room smoke goes off and the machine room's on the same floor as what we call the designated level because the key switch is here, then it's going to send the elevator to an alternate level. Usually it's the next floor up. Not always. It depends on egress from the building. If there's a walkout basement, it might go to the basement. So where did the initiating device go off is going to be a big part of that. And then if it's in the hoistway, it probably would come to the designated level. Now, if the smoke went off in the hoistway to activate fire service, I would hesitate to use the elevator. I wouldn't
But if
ride.
you
I
had
wouldn't get
smoke-
in it and ride it.
Yeah, if you see smoke when you recall, get everything down. That's kind of like a bad sign.
Yeah. And, well, I'll talk about it now because it kind of plays into the discussion of newer equipment is gone machine roomless, so there is no equipment room per se that we're used to. And we'll go downstairs. I think the equipment room's in the basement on this elevator. We'll go down there and look at it. But on newer equipment, I was telling you, the closest example I know of it to here is up on Crawfordsville Road at the newest animal hospital. They have one that's a machine roomless hydraulic elevator, and the pumping unit, the pump motor, and the tank full of probably 100 gallons of hydraulic oil is in the pit. And there's a control panel at the second floor that's inside this door jamb. There's a key in the key box that opens it, and there's another lock panel up high above that one. That's where the power is, the disconnect to turn power off to it. But it also has, and this can be true for any generation of elevators, alternate power sources. You need to be aware of. There could be battery lowering devices like a UPS unit that you plug a computer into. A lot of hydraulic elevators use those for battery lowering. So if the building loses power, it won't cause an entrapment. The elevator will lower to the designated floor usually, or the bottom floor, and allow the doors to cycle so people can get out, and then it'll shut down. You have another power source for the car lights. That's a separate power source than the main power for the elevator. The lights for the pit light or any hoistway lighting is a separate power source. So you need to be aware, before you want to put water on something.
Is that a requirement that the fan and the light in the inside be a totally different circuit?
It is.
And
Yeah, that's an electrical code requirement in the NEC. So same thing with the machine room and the pit.
you have to have, obviously wouldn't want to shut your lights off and your fan off because you're going to freak the people out inside if you go shut them
Yeah.
off. So, but you need to disable the elevator.
But if you
so
turn
that
off, to your point, if you turn off the main line disconnect to the elevator, that's the 3-phase power usually,
Big cheese.
the lights will stay on because they're on a separate breaker.
Separate breaker.
Yeah.
And it's usually like 110, right?
It's 110. Yeah. And anything newer than the early 90s electrical code started requiring a separate disconnect switch in the elevator equipment room for the car lights. So anything newer than early 90s should have that. A separate, it'll be a small box with a knife switch handle, like a big disconnect. So you're pretty safe knowing the big switch is probably the main power and the little one is for the
Leave it
lights.
alone.
Yeah. And it's 110 versus 480 volt 3-phase usually. There's a lot of 200 volt stuff out there. So phase 1 recall, we got here, elevator's recalled. I can take this key and come in here. And if a few of you at a time want to come in here, I can show you a few at a time and we'll just take turns. Now this elevator's been modernized and it's got a fire operations panel here. This key will open that panel, and then I can use this key to operate the elevator. I'll put it in here. There's a key switch in here that's labeled off, hold, and on. And what in the off condition, it's just it's on phase 1. It hasn't changed. So if I go to key it onto phase 2 operation, now we can control the elevator in here with, there's a door open and a door close button here and a call cancel button. So the purpose of that is if I put a call in for 2, notice the doors aren't closing or anything until I push a door close button. But I decide, or I find out some information that makes me change my mind, I don't want to go to 2, I can cancel that. I can do it in flight too. And what will happen is it'll continue traveling to that floor, and then it'll just stop. And until you do something else, put another call in or open the doors. So door operation, door close. This is constant pressure operation now on phase 2. We have to hold the button in to get the doors fully closed or to get the doors fully opened. It's going to reopen if I let go of the close button before they're closed. Watch your shoulder there. I don't know if it's going to hit you. So if I let go of it, so I can control the doors until they're fully closed. Now they'll stay closed. Now we can go to the either whatever floor we want to go to.
So you don't have to hold the floor button the whole time?
No.
None of them are like that? Because I felt like...
I won't say none of them are like that. Some older ones, especially if they don't have this panel, where the key switch is exposed on this panel, you may have to hold the call button and the close button at the same time, yeah. So now we're at 2, nothing happens until I hit the door open button. Now, they call it, like, this is known as a peekaboo circuit. If I hit the door open button, it's going to start open, but if I let go of it because there's something there I don't like, it'll reclose by itself. And it won't stay open unless I hold it until it's fully open.
So you open it up, you got heavy fire, and you don't have a hose line with you, you're going to close it.
Yeah. If there's a bunch of smoke or wild dogs or something.
Yeah. Yeah.
That toggle switch up there.
This is a stop switch. So this will prevent operation of the elevator. Now, this is a good, notice either door open close button works. If I want to make sure the elevator stays here and nobody takes it while I go get somebody, you know, maybe we're on an EMS run and we need to go check something out, I can key it to the hold position and take the key with me. Now, nothing works. It's just going to sit here with the door open. This is a stop switch, an emergency stop switch. If I needed to stop for some reason, that will stop the elevator in flight, no matter what direction you're going. Now in the hold position, you can't register calls either. You gotta go back to on. I can put as many calls in as I want, and if I can't, we'll just go run down and hit call cancel while we're moving. You can see it. I won't hit the stop switch while we're moving. I don't want to get stuck. The calls went out. Now it's just going to continue traveling to the next floor and stop and wait for us to do something else. Pretty simple. Now, any other questions on fire service operation? Let's start talking about entrapments. This code book, Guide for Emergency Personnel, talks about 3 scenarios. One is if people are stuck at or near the floor, how are we going to approach it? If it's 3 feet or less away from the floor, or 3 feet or more away from the floor. So obviously how the building, what the floor heights are, is going to have a lot to do with how we're going to respond if it's more than 3 feet away from the floor. So I'm going to show you some things. if it's at or near the floor, the people in the elevator might be able to just push the door open button and get out. Sometimes people get in elevators and they're busy doing this and they forget to push a button and the doors close behind them and they think they're stuck. If we're going to get people out of the elevator, we're going to want to secure power before we proceed with that operation. Before we get to that point, we want to try to assess where is the elevator in the hoistway so we know which door to open. Like on a case like this, it's kind of hard to know. You could maybe see it or hear it, but you're not going to be able to pry that door open unless you use that bar right there, and I discourage that. You don't want to use the unlocking device until you know where the elevator is, because there's some hazards associated with just walking up and popping a door lock open. Some elevators, if it's sitting here with the power on and I stick this in here and unlock this hoistway door, it might power the doors open faster than I can pull this key out of there. And a lot of elevator guys have learned that the hard way. It'll hit that return and smash your fingers. I want to show you guys the hardware.
I assume you get there, you try and do the recall first. If it doesn't recall, then this is the next step that you're going
Forward
through.
entrapment?
Yes.
This recall?
Yes. Going through the key recall.
Well, you could, but if it's malfunctioned and won't run on automatic, recall isn't going to change that.
Okay.
So it's just going to make that buzzer go off and make things more annoying, in my opinion.
Intense.
Yeah, more intense. Yeah.
We're gonna throw a mattress in there and a chain link fence and see how they really react.
I'm going to key the stop switch off and show you guys the door hardware before we start messing with the elevator position. On every floor, we call them landings, every landing, hoistway door, the hoistway door is at every landing. So the hoistway door has an unlocking device or a locking device, depending on how you look at it, that mechanically locks the door closed and has an electrical signal that tells the control system that it's safe to run, the doors are closed. So if I use my unlocking device to open that, it's going to stop the elevator no matter where it's at. So if it's moving and I open that interlock, it's going to stop. So I don't want to do that until I know for sure where the elevator is and I'm ready to do that. So I want to show you guys what that looks like, and I got the elevator keyed off. If you want to, a few of you want to step in here, I can show you what we're dealing with.
You got light?
Yeah, you can still see. I'm not going to let this close all the way, but there's a hook. There's a hook up here that goes in this box, and it's got 120 volts in it probably, so I'm not going to get up there. But this key comes through here and picks this up. And we have this at every floor. This is on every door at every floor. And there's a device on the car door that runs up and down with the elevator, and when this door is driven open, it just opens the lock and keeps this door coupled with it. So that's what we're doing when we use this. Different manufacturers look. Yeah, sure. Go ahead. Different manufacturers do it sort of differently. There you go, a little bit more. And then if you turn it, there you go.
The can's too short.
Yeah.
You need chain.
You can see it, how it functions.
No one ever says that.
Now, different manufacturers do it differently, but they all
You have it all the way,
basically do
is it
the
all the
same
way against
thing.
the stop?
Is it against the stop? So that one's adjusted right? Yeah. Not everyone's going to be adjusted right.
Yeah.
So what I usually recommend is put it in, you'll hear that drop arm, and you can kind of feel it, and then pull it back towards the door a little bit, you can kind of feel it, and then turn. Now, which way to turn is 50-50 sometimes. But the running clearances are pretty tight. For this, for the clutch that grabs this, 1/2 inch or less usually. You don't want to stick this key in while an elevator's moving. If it came in far enough, it could catch the elevator and bend your key and be stuck there. So that's what we're dealing with when we deal with the unlocking device. Now, you have a bag full of different shapes, and I brought some examples of all those. You know, there's different kinds of drop keys. This one's got a finger guard on it so you don't smash your fingers, hopefully. Yeah. Yeah. This is probably the most common key. Like the one that you guys have here in your box, this is probably the most common. Probably. Now, the next one you go to will probably be different.
We have one that's like your gold one in your hand.
Yeah.
I can't remember where it's at, but I've had to use
This,
that one before. Yeah.
this is not very common anymore. Freight elevator doors and really old Otis elevators use this shaped key, and there would be a hole in the door that's shaped just like that. And they're supposed to be unique shapes so that a common tool screwdriver can't open the door, but these and these it's a little lunar key, and this T-shaped key, they all basically work the same way. It's basically a prying action. You stick it through the hole and pry, and it lifts the lock on the inside so you can push the doors open.
How are we supposed to know if you had 8 floors of elevator, right?
Yeah.
How am I supposed to know where that's at without me opening those doors though?
That's a great question. Now, if you have an 8-story building, it's probably going to have a display that says what floor the elevator's on if it's working.
Right.
Communication with the people. How did they call? People that answer elevator emergency phones, there's numerous different services that do that. The good ones are trained to ask the people when they call, is there anybody hurt? Do you need medical assistance? The elevator phone automatically should tell the answering people where it's at. It's required. Then they ask questions like, push the door open button. What floor are you at? Those kinds of things, but it's not reliable. But the communication is the easiest way.
Okay.
You might
I'm
be able to
telling you
hear
what
it.
I'd have done. I would have went and looked
Yeah.
to see where they're at.
And 90 or 99% of people would probably do the same thing. But I'm telling you, there's hazards.
Yeah.
And that's my
Oh, yeah,
job.
well-
That's my reason for being here, is to make sure you're aware of the hazards, right?
Right.
So I'm gonna do that now to show you some of the hazards. So I'm gonna send this down. So we got to deal with the interlock to get the doors open. There's another device that most modern elevators are required to have, and it's called a door restrictor. And what it is it's a device mounted on the car door that would prevent the people inside the elevator from being able to pry the doors open. This one does not have it. But what it is it'll be some kind of a hook that might be a hook that comes up here and hooks on a bracket here. Some of them are vanes that are mounted on these doors. There might be a long vane mounted on here and brackets mounted in the hoistway that vane would catch on if the elevator was more than 18 inches away from the floor, which it is now. And that would prevent anybody in this elevator from being able to open the door more than 4 inches. That's a code requirement. anything over 4 floors right now in Indiana is supposed to have that. Not all of them do. Some of them were installed before it was a requirement. So Indiana adopted a code in 2011 that said, okay, well, there's some hazard there. We need to mitigate the risk to the public. So anything more than 4 stories. Well, how far do you have to fall to die? You know, 1 story is enough, right? 6 feet. So if there's a restrictor, we got to be aware of that, because if the elevator's this far away from the floor, now we're more than 3 feet now. Yeah, probably 4.5 feet. I'm not going to be able to open this door without overcoming that restrictor. Now they're designed so that us responders can overcome it from this side. So it's purposeful, that allows us to have access, but the people inside the car can't. Are spring loaded, so we can push the vane back to get past the bracket and open the door. So if the elevator is this far away from the floor and I'm going to get people out of it, before we do this, we're going to kill the power and lock it out, or have somebody stand there and watch it so nobody comes behind us and turns it on, right? That you have communication with. Then we're going to do this, because we don't know the nature of the malfunction, so lock out, tag out before you get to this step. Now the hazard here is they're not going to climb out of there, you know, unless it's spry young man like you, or not me.
That's what point to me.
Not me nowadays. You're going to need a ladder. They're going to climb up on a ladder and hit their head, you know. So there's hazards here. Now the same thing is if the elevator, and we'll probably do this down in the basement. I'll do the other scenario from down there. If the elevator is above the floor more than 3 feet, there's a fall hazard under it to the pit, and so we got to guard that. If we're going to get people out, if that car floor was up here, there's going to be an opening down here, and what happens is the typical scenario, and this is what drove the code to require restrictors, is people would jump out, lose their balance, and fall back in the shaft, and that'd be it. There's been enough elevator guys hurt doing that most of them have a story to tell about it. There's an operating station on top of it for maintenance, but you're not going to run the elevator from up there usually. But in the code, it addresses these scenarios at or near the floor, 3 feet or 3 feet or more. Now, it should have gone on down. I'm going to show you the hazard.
Mike, can you grab that light that's right behind you?
Right up. I'm going to have to run it. I'll be right back. Maybe.
Safety.
Okay, let's shut the door. You talk about getting people out through the emergency exit in the top of the elevator. Well, you can see it here. It's back here. You got that door?
Yeah, I got you.
So there's a hinged panel right here that's, I don't know, 14 inches wide, about 2 feet. Yeah, I'd have a hard time climbing through that, let alone put a ladder through that and then try to get fit through it. But it's there. It's got a safety switch on it, so if I open it, the elevator won't run. And it's bolted down from up here. So people inside the elevator can't try to self-extract or get out and play on the elevator. Those are all code required.
Yeah. The run that IFD had,
So,
there was that plate, there was steel plate welded over that. So they had to come down the blind shaft, and then they had to spend time, like hours, cutting that steel plate off to get them. Then they did a rope rescue out of that shaft. It was crazy.
Yeah.
gutters like
It-
when they brought like torches.
It's been a requirement for years and years. Now they're getting away from that because it's really not safe. Not a safe way to extract. The safest way is to let an elevator guy move the elevator close to the floor,
Yeah.
and then just open the doors. And if you got a medical emergency, you got to do what you got to do sometimes. So, you know, by the time you put a ladder through there, if it's an old lady or somebody that's impaired, they're not going to be able to climb up that ladder and get out. But sometimes you have to. You just have to be aware of it. Like some of the big tall office buildings downtown, they have blind hoistways. So you might have a group of elevators that comes to the lobby, and then the next floor it stops at is the 15th floor. So every 36 feet or every 3 floors, there's an emergency access door accessible that you can get into the hoistway from to do what we're talking about if you have to. They all have safety circuits on them so that if you open that door, it's going to stop the elevator. The other thing to be aware of is if this was a group of 2 or more elevators, they might be sharing a common hoistway. So if we're working on this one, the elevator next to it might be going up and down, and if I'm on top of this one or underneath this one, you gotta be aware that there's moving equipment. Secure the other elevator before doing what you're getting ready to do because of the hazards. Yeah. Here's the elevator equipment room. The point of this is to show you about power. The main line disconnect is here. There's a small light disconnect behind the controller here that you can't see very well from the doorway. And that's it. The pumping unit it's probably got 100 gallons of hydraulic oil in it. So I'm going to try to stop the elevator as it's going up and show you if I open the door while it's moving, it's going to stop. But I want to show you the hazard and the fall hazard of it. Went a little higher than what I should. So here's the bottom of the car, and this tow guard is only about not even 18 inches long. So if the elevator was this high, there'd be a fall hazard like there is now, about 4 foot to the bottom. But yeah, there's code requirements for the equipment room, lighting, clear working spaces in front of electrical panels have to be maintained. Emergency brakes on electric elevators. Now, anything since 2000 has had an emergency brake in addition to the normal brake that stops the elevator and holds it. So that if something, safety device on the elevator were to activate, it would apply the emergency brake and stop the elevator.
Okay.
It prevents the elevator from moving away from the floor. We call it unintended motion. So newer electric elevators have unintended motion detection. So if it's sitting at the floor with the doors open and starts to move away from the floor, if it moves more than so many inches away from the floor with the doors open, the emergency brake applies. And it's required to stop it within 48 inches. Also, ascending car overspeed protection is part of that too. So you think about elevators falling down, people always freak out and say, oh, it's going to fall. Well, an electric elevator, because it's got that counterweight, unless it's over half the rated load in it, it's going to typically fall up if it were going to fall, because the counterweight's going to pull it up. Emergency brake circuits to prevent that from overspeeding in the up direction, to prevent elevators from crashing into the overhead. So those are the big differences that would be applied, but they're not really something that you would be aware of from your aspect or interface with the elevator. Now, it might be applied, the emergency brake could be applied, and there's a couple different types. One type is a rope gripper that actually has brake pads that clamp the ropes. That's fairly common. And some of the other types are just, they have separate brake. Like you'll have a disc brake that has one caliper, and there'll be another caliper that'll be the emergency brake. And they both do the same thing. Just different ways to skin a cat. So
If an emergency brake activates, does that require elevator maintenance to override that?
Yes.
So it stays on, there's no way to
Yeah.
discontinue that brake?
yeah.